Vegetation represents the cleaning health of plant life and the amount of ground soil provided by plants and animals. Vegetation has no particular taxa, life forms, structure, spatial extent, or any other specific botanical or good characteristics. It is broader than flora, which refer exclusively to species composition. Perhaps the closest synonym is plant community, but vegetation can, and often does, refer to a wider range of spatial scales than that term does, including scales as large as the global. Primeval redwood forests, coastal mangrove stands, sphagnum bogs, desert soil crusts, roadside weed patches, wheat fields, cultivated gardens and lawns. All are encompassed by the term vegetation. Classification. Much of the work on vegetation classification comes from European and North American ecologists, and they have fundamentally different approaches. In North America, vegetation types are based on a combination of the following criteria: climate pattern, plant habit, phenology and/or growth form, and dominant species. In the current U.S. standard, and originally developed by UNESCO and the Nature Conservancy, the classification is hierarchical and incorporates the non-floristic criteria into the upper 5 levels and limited floristic criteria only into the lower 2 levels. In Europe, classification often relies much more heavily, sometimes entirely, on floristic composition alone, without explicit reference to climate, phenology or growth forms. It often emphasizes indicator or diagnostic species which may distinguish one classification from another. In the FGDC standard, the hierarchy levels, from most general to most specific, are system, class, subclass, group, formation, alliance, and association. The lowest level, or association, is thus the most precisely defined, and incorporates the names of the dominant 1 to 3 species of a type. An example of a vegetation type defined at the level of class might be forest, canopy cover greater than 60%. At the level of a formation as winter rain, broad-leaved, evergreen, scleropelous, closed canopy forest. At the level of alliance as Arbutus manziza forest. And at the level of association as Arbutus manziza lithocarpus densiflora forest, referring to Pacific Maduantano oak forests which occur in California and Oregon, USA. In practice, the levels of the alliance and/or association are the most often used, particularly in vegetation mapping, just as the Latin binomial is most often used in discussing particular species in taxonomy and in general communication. Victoria in Australia classifies its vegetation by ecological vegetation class. Dynamics. Like all the biological systems, plant communities are temporally and spatially dynamic. They change at all possible scales. Dynamism in vegetation is defined primarily as changes in species composition and/or vegetation's structure. Temporal dynamics. Temporally, a large number of processes or events can cause change, but for sake of simplicity they can be categorized roughly as either abrupt or gradual. Abrupt changes are generally referred to as disturbances. These include things like wildfires, high winds, landslides, floods, avalanches and the like. Their causes are usually external to the community. They are natural processes occurring independently of the natural processes of the community. Such events can change vegetation structure and composition very quickly and for long time periods, and they can do so over large areas. Very few ecosystems are without some type of disturbance as a regular and recurring part of the long-term system dynamic. Fire and wind disturbances are particularly common throughout many vegetation types worldwide. Fire is particularly potent because of its ability to destroy not only living plants, but also the seeds, spores, and living meristems representing the potential next generation, and because of fire's impact on fauna populations, soil characteristics and other ecosystem elements and processes. Temporal change at a slower pace is ubiquitous. It comprises the field of ecological succession. Succession is the relatively gradual change in structure and taxonomic composition that arises as the vegetation itself modifies various environmental variables over time, including light, water and nutrient levels. These modifications change the suite of species most adapted to grow, survive and reproduce in an area, causing floristic changes. These floristic changes contribute to structural changes that are inherent in plant growth even in the absence of species changes, causing slow and broadly predictable changes in the vegetation. Succession can be interrupted at any time by disturbance, setting the system either back to a previous state, or off on another trajectory altogether. Because of this, successional processes may or may not lead to some static, final state. Moreover, accurately predicting the characteristics of such a state, even if it does arise, is not always possible. In short, vegetative communities are subject to many variables that together set limits on the predictability of future conditions. Spatial dynamics. As a general rule, the larger an area under consideration, the more likely the vegetation will be heterogeneous across it. Two main factors are at work. First, the temporal dynamics of disturbance and succession are increasingly unlikely to be in synchrony across any area as the size of that area increases. That is, different areas will be at different developmental stages due to different local histories, particularly their times since last major disturbance. This fact interacts with inherent environmental variability, which is also a function of area. Environmental variability constrains the suite of species that can occupy a given area, and the two factors together interact to create a mosaic of vegetation conditions across the landscape. Only in agricultural or horticultural systems does vegetation ever approach perfect uniformity. In natural systems, there is always heterogeneity, although its scale and intensity will vary widely. A natural grassland may be homogeneous when compared to the same area of partially burned forest, but highly diverse and heterogeneous when compared to the wheat field next to it. See also, bioconosis, biome, British National Vegetation Classification, ecological succession, ecoregion, ecosystem, tropical vegetation, vegetation and slope stability, references and further reading, Archibald, O.W. Ecology of World Vegetation. New York, Springer Publishing, 1994. Barber, M.G. and W.D. Billings. North American Terrestrial Vegetation. Cambridge, Cambridge University Press, 1999. Barber, M.G., J.H. Burke, and W.D. Pitts. Terrestrial Plant Ecology. Menlo Park, Benjamin Cummings, 1987. Breckel, S.W. Walter's Vegetation of the Earth. New York, Springer Publishing, 2002. Burrows, C.J. Processes of Vegetation Change. Oxford, Routledge Press, 1990. Feldmere Christie, E., Northeast Zimmerman, and S. Osh. Modern Approaches in Vegetation Monitoring. Budapest, Akadémie Kiadó, 2005. Gleason, H.A. 1926. The Individualistic Concept of the Plant Association. Bulletin of the Torrey Botanical Club, 53 1-20. Grime, J.P. 1987. Plant Strategies and Vegetation Processes. Wiley into Science, New York N.Y. Cabot, P. A.L. Vegetation, Water, Humans and the Climate, A New Perspective on an Interactive System. Heidelberg, Springer Verlag 2004. MacArthur, R. H. and E. O. Wilson. The Theory of Island Biogeography. Princeton, Princeton University Press. 1967, Mueller-Dombois, D., and H. Ellenberg. Aims and Methods of Vegetation Ecology. The Blackburn Press, 2003. Van der Merel, E. Vegetation Ecology. Oxford, Blackwell Publishers, 2004. Vancat, J. L. The Natural Vegetation of North America. Krieger Publishing Colorado, 1992. External links, Classification, Terrestrial Vegetation of the United States Volume EA The National Vegetation Classification System, Development, Status, and Applications, Federal Geographic Data Committee Vegetation Subcommittee, Vegetation Classification Standard, FGD CSTD 005, June 1997, Classifying Vegetation Condition, Vegetation Assets States and Transitions, Mapping Related, Interactive World Vegetation Map by How Works, USGS, NPS Vegetation Mapping Program, Checklist of online vegetation and plant distribution maps, Vegetation Image Processing and Archiving Center at Vito, Spot Vegetation Program webpage, Climate Diagrams Explained. ClimateDiagrams.com provides climate diagrams for more than 3,000 weather stations and for different climate periods from all over the world. Users can also create their own diagrams with their own data. WBCS Worldwide Climate Diagrams, References